Hello, I'm Liebenbakker, and today I will explain to you how you can find out if a number is divisible by 7 or 13. It's a method I discovered some 40 years ago, and I'm sharing it with you today. So as you know, till now we have easy methods to find divisibility by 1, 2, 3, 4, 5, and 6, and also for 8, 9, 10, 11, and 12. But the method for 7 is missing. There are some methods, but they're based on multiplication. They're not so easy to calculate by head. So today I present the method with 3 simple rules that you can use for head calculation. So it means you see the number, you do the calculations in your head, and you find if the result is, if the number is divisible by 7, and also if it's divisible by 13. And it's, as I already said, based just on addition and subtraction. So the first rule is the basic rule. It explains that you can add 1 in one rank, subtract 1 in the next rank, and add 1 in the third rank, and that will preserve divisibility by 7 and 13. So by applying this rule on any number, you preserve divisibility by 7. The goal is to make the large number smaller and smaller until you find a 2-digit number, which is easy to see if it's divisible by 7 or 13. So it's easier with an example. So let's take 3572 as a number. So when I apply the rule, I subtract 3 in the first rank, I add 3 in the second rank, and I subtract 3 in the third rank. So 3 minus 3 is 0, so this digit disappears. 5 plus 3 is 8, 7 minus 3 is 4, and we preserve the 2. So if 3572 is divisible by 7 or 13, then also 842 is divisible by 7 or 13. So again, here the limiting number is the digit is the 2. So I can subtract 2, add 2, subtract 2. So 8 minus 2 is 6, 4 plus 2 is also 6, and 2 minus 2 is 0. So this digit also disappears. I end with the number 66, and as we know, this one is not divisible by 7 or 13, so the original number is not divisible by 7 or 13. By the way, for a random number, we have about a 20% chance to find a divisibility. The second rule is a rule that's already known on the internet. It says that you can add 1001 and subtract 1001 on any number, and that will also preserve the divisibility. So let's take this number 35764 as an example. So we want to get rid of the first digit, so we subtract 3 in the first rank and in the fourth rank. So 3 minus 3 equals 0. We preserve the 5 and the 7, 6 minus 3 equals 3, and we preserve the 4. Again, we apply the rule on the next rank. Here the 4 is the limiting factor, so we subtract 4 in the fifth and in the second rank. 5 minus 4 is 1, we preserve the 7 and the 3. 4 minus 4 is 0, so we get rid of this digit. So we end with a number 173, where we apply the rule number 1. So we subtract 1, add 1, and subtract 1, which gives us 82, which is not divisible. So we know the original number is also not divisible. In fact, this rule is a consequence of the rule number 1. So let's take this number 35764. I will show it like to you. So let's here subtract, add, and subtract 3. So we subtract 3 from the first rank, we add 3 to the second rank, we subtract 3 from the third rank, and we preserve the other numbers. And now we do the same on the next level. So we subtract 3 here, we add 3 there, and we subtract 3 there. And that's the number we find in the second line here. So in fact, applying the rule number 1 on 2 consecutive places is rule number 2. Rule number 2 is more powerful because it's easier and it advances a lot quicker. So when you're trying to analyze a number, you will first apply the rule number 2 and only at the end the rule number 1. I presented rule number 1 first because it's the basic rule. Then the third rule. In some cases, you can get stuck when you meet a 9 or a 0. So you cannot add any numbers to the 9 or you get spillover. You cannot subtract from 0 because then you have to borrow. So there is the third rule, which means you can add and subtract 91 wherever you want. So example number is 39704. I have a 9 over here, so I cannot subtract anything from the 3 because then I would have to add to the 9 and I don't want to have this spillover. But the rule tells me I can subtract 91 on this place, so I subtract the 9 from the 9, which gives me a 0, and from the 7 I subtract the 1, which gives me the 6. So now I have this equivalent number 30604. Let's say I want to apply rule number 2 on the 3, so I should subtract 3 here, but also there. I cannot subtract 3 from 0, so here I add 91. I add 9 to the 0, which gives me 0. 4 plus 1 gives 5, so I have now this number. So now I am no longer stuck. I can now easily continue with this number 30695. I can subtract 3, which gives me this number. Now I can again apply rule number 1 with quantity 3. So I subtract 3, I add 3, and I subtract 3. Okay, now I can again apply rule number 3. So I subtract the 91. And now I can again apply rule number 1. So here the limiting number is the 1. So I subtract 1, I add 1, and I subtract 1. 21 is divisible by 7. So my original number is also divisible by 7. When I explain it, it looks a bit cumbersome, but of course, if you're not explaining and just doing, it goes a lot quicker. Let's show some examples. So I use this number that a lot of you will recognize as a way to demonstrate the method. So 142857. So let's first apply rule number 1. Yeah, I will deliberately ignore rule number 2 just to give you some example of how rule number 1 works. So to eat away the 1 at the first place, I can subtract 1, add 1, and subtract 1. So -1, +1, -1, and I preserve the other numbers. So from 6 digits, we're now down to 5 digits. Okay, now I want to eat away the 5. So this 0, it's a 0, we can ignore it. So 5 minus 5 is 0. 1 plus 5 is 6, 8 minus 5 is 3, and we preserve the further numbers. So now we're down to 4 digits. We continue, so these digits are gone. Here the limiting number is the 5. I can only subtract and add 5. So 6 minus 5 is 1, 3 plus 5 is 8, 5 minus 5 is 0, and I preserve the 7. Okay, so now to eat away the number 1 at the start, I have to apply rule number 3. That's why the rule number 3 exists, just to be able to continue with rule number 1 and 2. So here I add 91, which is easy because, well, there's no spillover, there's no borrowing. So I get this number. Now I can continue by with removing the ones. So I do -1, +1, and -1. So now I'm down to 3 digits. Okay, now I will attack the 9. So here the limiting factor is the 8 in the middle. I can just add 1. So I subtract 1, I add 1, and I subtract 1. So I get this number. Now, to continue, I have to do away with the 9 in the middle. I'll do this by subtracting 91 again. So I preserve the 8, and here I subtract 91, which gives me 806. And now I can continue with rule number 1. Here the limiting digit is the 6, so I subtract 6, I add 6, and I subtract 6, which gives me a 2-digit number, 26. 26 is divisible by 13, so I know my original number is also divisible by 13. Okay, this goes a lot simpler when I use rule number 2. So I start with the same number. Yeah, to apply rule number 2. So here I can start by subtracting 1001. So 1 minus 1 is 0. I leave the 2 middle digits alone, and then again I subtract 1. This leaves me with this 5-digit number. Now I can address the 4, so I subtract 4004. 4 minus 4 equals 0. The 2 and the 7, I leave them alone. 5 minus 4 is 1. And then the 7 is left alone. I continue with attacking the 2. So here I can subtract 2002. Subtract 2, leave the 7 and the 1 alone, and subtract 2 again. So now I have a short number, only 3 digits. So now I can continue with rule number 1. So here the limiting factor, the limiting digit is the 5 at the end. So I can subtract 5, add 5, and subtract 5, which gives me 260. And it's the same number as I found earlier. So again, this is a proof that my original number is divisible by 13. You don't always find the same number. So for instance, in the example in the slideshow, it ends with 78, but 78 is again divisible by 13. So the final goal is to find if it's divisible by 13. So the result of the conclusion is the same. There's a bonus rule for bigger numbers. So if you have a piece of scrap paper, you can apply rule number 4, which explains that you can chop the big number in groups of 6 and then add all these numbers together. So if you have this big number of 17 digits, you chop it in parts of 6. Well, here I had to add a padding 0 because the 4 is the most significant number, should be added with the 7 and the 1. So we put all these numbers under each other. We do the addition, which is something you should be able to do on paper. And then you find this number, which is a lot smaller than that number. So this number, well, we can now apply the rules 1, 2, 3, 4, 5, 1, 2, and 3. Again, here I should add 91 to be able to eat away the 1. So 3, 7, 8, and then I preserve these numbers. This one has gone. 3 minus 3 is 0. 7, 8 I preserve. The 1 stays and these stay. So here the limiting number is the 6, so I can subtract 6. I preserve these numbers. I get in 6 minus 6 is 0, and I keep the 9. Here I have to add the 91. Okay, here I have a problem. If I add 91 to this one, if I add 1 to the 0, it will spill over. Yeah, that's one of the rare places where stuff spills over. And now I can again subtract 1, add 1, and subtract 1. And this is a rare case where we end on 91, which means that the original number was divisible by both 7 and 13, because 91 is divisible by 7 and 13. And that's not a surprise, because the original number is the period of 1 divided by 81. Okay, that's these were the rules. In the end, in this case, you end with a 2-digit number, which is still different from the methods 1, 2, 3, 4, 5, 6. You end with a 2-digit number. So if you're interested in divisibility, then you use method A. So if people that are interested in the matter, they already know the multiples of 7 and they know the multiples of 13. So for 7, it's easy. Well, 0 is a multiple of everything. The green numbers you learned through the tables of multiplication, so you also know them. 77 is also easy, so 84 is the only hard one to remember. 91 is the base of this method, so you should know it after this movie. And 98, if you subtract 91, you will find 7, so then you know it's divisible by 7. For 13, yeah, you have to learn them by heart. 13 is, well, they're here, you can see the numbers. When you memorize them, you know it. The other method, if you don't want to know things by heart, then it's splitting the remaining 2-digit number in prime factors. So if you're interested in this is something that's very easy for you. So let's say you find 84, you see it's divisible by 2, so you divide by 2, you find 42, divide again by 2, you get 21, which you know is divisible by 3, so you divide the 3 away, and then you find the 7. Let's say you find 78, it's an even number, so you divide by 2, then you find 39. 3 and 9 are both divisible by 3, so you know this number is divisible by 3. It's an easy division, you find 13. Okay, this one is divisible by 13. Let's say you find 66. It's again an even number. Divide by 2, you find 33. Divide by 3, you find 11. Okay, this one is not divisible by 7 or 13. Yeah, okay. I think it's clear by now. So with the rules, you reduce the big number to a 2-digit number, and then for the 2-digit number, you apply the end game. So the conclusion of my explanation is we found a method to find if a huge number is divisible by 7 and 13 without having to do the division. It's based on addition and multiplication. It's easy to remember. It can be calculated from the head. You don't need paper, you don't need a calculator. You can just do it by looking at the number. And the good news is that now we have easy methods to find divisibility up till the number 16. So for 14, it's obvious you combine divisibility by 7 and 2. 15 was already a known method because you combine 3 and 5. And 16 is just a step up from divisibility by 8. So my name was Lieven de Bakker, and now you know how to find divisibility by 7 and 13.